Hello, welcome to my channel. I'm here to do my 100 Leetcode challenge. Today we have Leetcode 199, binary tree right side view. This is really classic question for binary tree. So let's take a look. Given a binary tree, imagining yourself standing on the right side of it, return the value of the node you can see ordered from top to bottom. So here's a 2D view. So this is a tree, a binary tree, but the output will be looking from the right side, from every row, the rightest row, the rightest node on this tree will be outputted in this array. And that should be it. And you see, it can only need one node from every row. So it's kind of similar to how you manage row by row. So at that time, the first thing we come up is a list or array to store every of this node from every row. Now the idea of this one is now we have the array to store the current rows node. At first we put one node, the node in here. Right. Now you have one, because we want to see the right side first, the most right side first. And you see this is not empty. What we need to do is pop this out, take out this one, and should go to the right side first and add that child in it. So after this, the order will be 3 to 2. So now in this case, we have the second row child. The first thing we need to do is take a look at the child in this order and do the same thing to get to the third row. Now we'll pop 3 out. Now, and in the second level, we know n equal to 2. N is the number of nodes in this row. So this row have two nodes. We only operate 2 times. First time, we take out 3. After take out 3, what we need to do is check 3's right side first to put the most right always first into this array, and then that's with -1. So in row 2, we still have one more node to do to process. And here we have 2. We pop this 2 out to get 2's children, which is 5. If 2 has left node, it will go to 5 first, and then we'll put another node later. So we have 2, get the right node first, which is 5, and then second row is done. So this process is done. Right. And at the time you add 3, now we add the third row. Third row, we have the first node right here. We put it to the output array, and then we process this. Now we have n equal to 2, and we do the same things again and again until we reach out all the nodes. And then you will find all the right side node, the most right side node for this tree. Without further ado, let's take a look at the code. Usually start with the template of having the output done. And we will return the output eventually. In between, another condition, check if the root equal to no. We just return output to save some time. We don't need to go through everything. What we need to do is have a list of 3 nodes to keep out all the nodes. List. First, in this list, like what we said, we will have list.add root node inside. So now we have the top node in here inside the array. What we need to do is while this array, this list is not empty, and we need to keep looping. Remember, we used how many nodes we have for this. We have n equal to list.size, and this is how many nodes for the current level. At this time we have 1, so we need to loop 1 time. Output add right away to add this get 0. The first node, to get the first node's value inside the output array. And now we have how many nodes we need to loop. For the current row, we have another while loop, checking n equal to bigger than 0, then we have a loop. Take out how many nodes for that list. 3 node is a current node we are processing, equal to list dot get 0. And after that, since you get the node already, then you can return, you can remove it. So you have this one, the current node is processing. So now you need to check how in here, for example, in here, now we have current is 1. We need to go to the right side first to put the node back into the array. If there's a node, and then go to the left side and put that in to the array for second row. If current has right side, T has right side, right? Then we'll put list dot add current dot right. We put current dot right node inside the list. If current dot left not equal to no, then list dot add current dot left. After that, minus and minus 1. So we finished 1 node already. And we finished how many nodes for this row, and we can jump to the next row. We save all the child for the current row to the list, and then we jump to the next row and then process the node right there. And after that, I think this should be good. Okay, and just great. Cool. And that's it for this question. If you have any question, please comment below and I will get to you as soon as possible. Then I will see you in the next video. Bye.